So suppose we want to find the inverse cos of 2, which sounds ridiculous, but now we have complex numbers. This is in fact possible. So we'll write it, we'll take cos of both sides and write cos z equals 2. And we'll keep z as x plus I, y. Then we can use that, we use this formula here. So we know therefore that 2 is equal to cos x cos y, and taking the imaginary part, well, the imaginary part of 2 is 0, so 0 is equal to sine x sine y. So we've got two simultaneous equations for x and y. We need to do a little bit of thinking. So we obviously know that it's impossible for z to be real. So if z is not real, that means that y cannot be 0. So if y cannot be 0, it means that sine x must be 0. Okay, so that now gives us various possibilities for x. It's basically saying that sine x must be 0, which means that that can only happen if x is n pi. Always say what you mean by n, so n is any integer. Okay. So now we know what x is, it's n times pi. Now cos of n pi is equal to either plus or minus 1. It's basically cos of n pi. N pi is equal to minus 1 to the power n. Now if n is odd, we get minus 1. Now think what happens if we put minus 1 into here, then we'll get cos y is negative. Now cos is always greater to plus 1. So therefore n, this is only going to work if n is even. So therefore we need that x has to be an even multiple of pi. So we'll just write it like that: x equals 2m pi, where we'll keep m as also any integer. That means that cos is definitely plus 1, and therefore y is simply inverse cos of 2. Now, remembering what cos actually looks like, cos looks like this. There's two possible solutions to that. So our final answer is going to be z is equal to x plus iy. So what is x? X is 2m pi, where m is any integer, and then plus iy. So we've got plus I, and y is inverse cos of 2. But remember, there's two solutions, so we need a plus or minus.